everyone, welcome again to our tutorial series. I am Teacher William, and in this video, we are going to study the topic, layers of the Earth. Our planet Earth has many layers because it was shaped by the geologic process that began at the start of Earth's origin. The differences of each layer are based on the compositions that make them up. So here are the different layers of the Earth. We have the crust, the mantle, and the core. Let us explore this, one by one. The Earth crust. The Earth crust is the outermost layer of the Earth. The crust is the part of the Earth right on top where people live. The Earth crust has a thin layer measuring 40 kilometers deep composed of solid rocks and minerals with temperature of 220 C. The crust is made up of large rocks. Earth crust is divided into two forms. We have the oceanic crust and the continental crust. These two types of the crust make up the surface of the lithosphere. And these two lies on top of the mantle. The continental crust. The continental crust is the layer of granitic, sedimentary and metamorphic rocks which form the continents and the areas of shallow seabed close to their shores, known as continental shelves. It is less dense than the material of the Earth's mantle and thus, floats, on top of it. Continental crust is also less dense than oceanic crust, though it is considerably thicker than the oceanic crust, mostly 35 to 40 kilometers versus the average oceanic thickness of around 7 to 10 kilometers. About 40% of the Earth's surface is now underlain by continental crust. The oceanic crust. Oceanic crust is found under oceans, and it is about 4 miles thick in most places. A feature unique to oceanic crust is that there are areas known as mid-ocean ridges where oceanic crust is still being created. Magma shoots up through gaps in the ocean's floor here. As it cools, it hardens into new rock, which forms brand new segments of oceanic crust. Since oceanic crust is heavier than continental crust, it is constantly sinking and moving under continental crust. The next layer of the Earth is the Earth's core. Earth's core is the very hot, very dense center of our planet. The study of Earth's interior is the most difficult because it is inaccessible. The information about Earth's core is from seismic information and computer models. Earth core has two parts. We have the inner core and the outer core. The inner core. Ing Lehmann, a seismologist, discovered in 1936 that Earth has a solid inner core. Earth's inner core is the innermost geologic layer of the Earth. It is primarily a solid ball with a radius of about 1,250 kilometers, which is about 20% of the Earth's radius or 70% of the Moon's radius. It consists mainly of iron-nickel alloy and is magnetic. It has temperature of about 6,000 degrees Celsius, almost as hot as the surface of the Sun. The pressure in the inner core is so great that the alloy cannot melt. For this reason, the inner core is mostly solid. The outer core. The outer core is made mostly of iron and nickel. The outer core is approximately 2,300 kilometers thick. It is very hot. The temperature is between 4,000 degrees Celsius and 5,000 degrees Celsius. Because of the very high temperature, the outer core is liquid. So therefore, the outer core is a liquid, while the inner core is solid. The boundary between the outer and the inner core is sometimes referred to as Lehmann discontinuity, named after the seismologist, Ing Lehmann. Next we have the mantle. The mantle is the longest part of Earth. It is the intermediate layer of Earth and is subdivided into lower and upper mantle. It is made up of molten rocks called magma. The magma circulates in currents determined by the cooling and sinking of heavier minerals, and the heating and rising of the lighter minerals. The mantle has a total thickness of 2,900 kilometers. The lower mantle. The lower mantle is hot and exhibits plasticity. The higher pressure in the layer causes the formation of minerals that are different from that of the upper layer. Gutenberg discontinuity is detected between Earth's lower mantle and the outer core as observed by changes in the seismic waves. It is 2,240 kilometers thick. The Gutenberg seismic velocity discontinuity between the Earth's mantle and core, named after the discovery of Benno Gutenberg, German-American seismologist. It is the boundary between the mantle and the core. Lastly, we have the upper mantle. The upper mantle extends from the crust to a depth of about 6,700 kilometers below the Earth's surface. It is mostly solid and its malleable contribute to tectonic activities. The upper boundary that separates the upper mantle from Earth's crust is defined by the sudden increase in seismic velocity. This is called MOHO, or Mohorovicic discontinuity, as noted by Andrija Mohorovicic in 1909. MOHO is 5 km to 10 km below the ocean floor and 20 to 90 km with an average of 35 km beneath typical continents. The asthenosphere, which is a zone of Earth's mantle lying beneath the lithosphere and believed to be much hotter and more fluid than the lithosphere. The asthenosphere extends from about 100 km or 60 miles to about 700 km or 450 miles below Earth's surface. The name asthenosphere was given by an American geologist Joseph Barrel in 1914. And that concludes our lesson for today. I hope you learned to our tutorial series. More educational videos will be uploaded. So don't forget to subscribe and press the notification bell for more video updates. See you again on the next video. Thank you very much. Good day and God bless you all.